In this third video, we will define a tool that will be of great use to us in evaluating trig functions of common angles, which will be the next video. So if we have an angle theta, then we define the reference angle to be the acute angle formed by the terminal side and the horizontal axis. So in this first angle that lands in the second quadrant, this angle, this acute angle, is our reference angle. In the third quadrant, again, to our x-axis, we have this acute angle. Fourth quadrant, this is our acute angle that is our reference angle. And even if we go beyond a revolution, or we go clockwise instead of counterclockwise, it's always the acute angle between 0 and 90 degrees, or 0 and pi over 2, that is our reference angle. So to find a reference angle, at first what we're going to do is just go ahead and sketch this angle. So 315 degrees, there's 270 degrees, and 270 degrees will land us, if we go beyond that, into the fourth quadrant. So therefore, our angle that's left over is 45 degrees. So if we draw that angle, that acute angle, to our positive x-axis in this case, we have 45 degrees. So the reference angle is 45 degrees. Now, let's look at 11 pi over 6. Now, whenever it comes to radians, it can be beneficial to look at the fraction without the pi. So we have 11 pi over 6. Let's just look at 11 sixths. 11 sixths as a mixed number is 1 and 5 sixths. So as we look at our angle 11 pi over 6, we're looking at 1 and 5 sixths of a pi. So this is 1 pi. Now we want 5 sixths of a pi, more than that. So 5 sixths is more than a half, but it's not quite a whole nother pi. So therefore, we land somewhere in the fourth quadrant. So how much is left over? We have 1 and 5 sixths pi, and a full revolution would be 2 pi, which 2 pi is 12 pi over 6th. And we want 1 and 5 sixths pi, so that means that what we have left over is a sixth of a pi. So the reference angle is pi over 6. Now as we deal with radians more and more, you'll see that radians are much easier to find reference angles for. So here, the 11 pi over 6 angle has a reference angle of pi over 6. Let's look now at 13 pi over 4. So again, let's draw our angle, and again, it doesn't have to be exact. So let's look at the fractional portion without the pi. 13 fourths is 3 and 1/4. So 3 and 1/4, we have 1, 2, 3. So this would be 3 pi. Now we want a fourth of a pi, which is not a half a pi. We now land in the third quadrant. So that was 3 and 1/4 pi. How much did we go beyond the 3 pi mark? We went a quarter beyond. So this is 1/4 of a pi. So the reference angle is pi over 4. So what are we noticing here? In the previous example, we had 11 pi over 6 had a reference angle of pi over 6. In this example, we saw 13 pi over 4 had a reference angle of pi over 4. Let's look at the next example in degrees. 570 degrees. So this is a measure counterclockwise. So there's 360 degrees. Now if I go another 180 degrees, that's 540 degrees. So I just need to go 30 more degrees. And so this measure is 30 more degrees than 540 degrees. And so our reference angle is 30 degrees. Now let's go back to radians. You're probably not as comfortable with radians, but hopefully after this example, we'll start to make some connections. Negative 14 pi over 3. So let's look at the fractional portion, and we won't even worry about the negative right now, because the negative just means that we're measuring clockwise in this case. So 14/3 equals 4 2/3. So now because we are measuring clockwise, this is 1 pi clockwise, 2 pi clockwise, 3 pi, 4 pi. Now we need to go another 2/3 of a pi. This would be half a pi. So 2/3 of a pi isn't quite a full pi. So we land in the third quadrant. So what is our reference angle? Our reference angle is this portion, and the measure of that acute angle is how much more do I need to obtain another pi? We have, this is 4 2/3, so I would need another third of a pi. So the reference angle is pi over 3. So let's take an inventory of what we found up to this point with radians. We saw that 11 pi over 6 had a reference angle of pi over 6. We saw 13 pi over 4 had a reference angle of pi over 4. Here we saw that negative 14 pi over 3 had a reference angle of pi over 3. Now, you'll notice that 11/6 is in simplest terms, 13/4 is in simplest terms, and 14/3 is in simplest terms. Now, when that happens, I can just look at the denominator, and that will determine the reference angle. So if we had something really complicated, say, like 29 pi over 3, the reference angle would simply be pi over 3. That's the pattern, and that's the beauty of radians. Now let's go to degrees. Negative 690 degrees. Well, that's measured clockwise. So we have 360 degrees plus another 180 degrees. This is now 540 degrees. Plus 90, that's 630 degrees. And that means that I need another 60 degrees. And if I were to go to the positive x-axis, that'd be 720 degrees. So, how much is this? Well, if this is 690, then this is simply 30 degrees. So the reference angle is 30 degrees. And these should have negatives. Because they're measured clockwise. But the reference angle is always a positive acute angle.